1.5 is the last section we will do in chapter 1. So that means you will probably have a chapter 1 test sometime this week. So be aware of that. Be prepared for that. But chapter 1.5 is titled Expressions Involving Absolute Value. Does anyone know anything about absolute value? If so, raise your hand and tell me. Anyone know anything about absolute value? Does everyone know what absolute value looks like? Okay.
I feel like absolute values
Absolute value is just two sets of bars. Does that look somewhat familiar? Okay. So, absolute value absolute value makes any number positive. Okay? And here's the reason. Absolute value is a distance. When you're measuring something in distance, do you ever make it negative? No. I live about 1.5 miles from Carl Albert. So I drove to school today. I drove 1.5 miles. When I drive back home, am I going to drive a negative 1.5 miles? No, it's just going to be another 1.5 miles on top of that, right? So distance is not measured in negative units. So, since absolute value is measuring distance, it is not negative. So, it's specifically talking about the distance a number is from 0. So 7 is a distance of 7 units from 0. Everyone okay with that?
Yes, sir. Yeah.
Negative 7 is also a distance of 7 units from 0. So it makes any negative number positive because it's talking about its number or its distance away from 0. Does that make sense?
Yes, sir. Yeah.
Everyone understand what an absolute value does or is?
Yeah.
Good. So, that's exactly what this slide here is saying. The absolute value of a number is its distance from 0 on a number line. So, if it's a positive number, it's going to stay a positive number because it's just the distance from 0. If it's a negative number, the absolute value of that negative number is a positive because we're still talking about distance from 0. Are we okay with that?
Yes.
Okay, I'm not going to spend a whole lot of time on this slide. I'm also not going to spend a whole lot of time on example 1. This is everything. You don't have to write it down. I just wanted to throw it up here for you guys. The accuracy of a meat thermometer is the positive difference between the temperature reading on the thermometer T and the actual temperature of the meat M. Complete the statements about which expressions are and are not equivalent to the accuracy of a meat thermometer. Shh. So, what does difference mean? Subtraction, right? Difference means subtraction. The temperature reading on the monitor, they're using T to represent that. The actual temperature of the meat, they're using M to represent that. So it wants the positive difference between the temperatures, the two temperatures. The one on the thermometer and the actual temperature. So that means I'm going to subtract those two numbers, correct? That's what difference means. So that would be either M minus T or T minus M. And notice it says positive difference. So how can I make a number positive? What are we talking about today? Absolute value. So to ensure that my answer is positive, I can put absolute value bars around it. So this one right here and this one right here are the expressions that are equivalent to the accuracy of a meat thermometer. Because it represents the difference of those two temperatures, the temperature on the thermometer and the temperature of the meat. And it's in the absolute value, so it's making it positive every single time. Does that make sense? These two are not accurate, equivalent. Let me rewind there. These two are not expressions that are not, or they are expressions that are not equivalent to the accuracy of a meat thermometer in all cases. Because if I've got a bigger number here for T, when I take the absolute value and then I subtract, that could turn out to be like 4 minus 7, which is going to give me a negative number. Does it want negative numbers?
No.
What's positive? Positive difference. So these two would not work. These two would work. Like I said, I'm not going to spend a lot of time on this slide. I just wanted to kind of throw that up there. Am I good to move on to example 2?
Yes.
Sweet.
Yes.
Evaluate the absolute value of negative 2xy plus 5y if x equals 6 and y equals negative 3. Any ideas what I'm going to do here? We've done problems similar to this in past sections of chapter 1. If it gives me an expression and values for variables, what do you think I need to do? Huh? Elaborate on that. Put what in where? Yep. So, anywhere I see an x in my expression, I'm going to replace it with 6. I'm going to replace that x with 6. Anywhere I see a y, I'm going to replace it with negative 3. Because that's what it tells me y equals. Are we okay with that?
Yes.
So, that's what I'm going to do right now. Anywhere I see an x, replace it with 6. Anywhere I see a y, replace it with negative 3. Is there any confusion with how I've plugged in?
No.
Now I'm just going to work it out using my order of operations. What do you guys think we need to do first? Yeah, I heard someone say multiplication. I've got multiple things of multiplication. So yeah, I'm going to do these 3 numbers all multiply together. What's negative 2 times 6? Negative 12. Negative 12 times negative 3. Positive 36. So negative times a positive gave me a negative. Negative times another negative gave me a positive. Now I've got 5 times negative 3, which gives me negative 15. We okay with my multiplication there?
Yeah.
Any confusion up to this point? Okay, what's next? Yeah, 36 minus 15. What does that give me? What?
21.
21. So now I have simplified everything inside my absolute value bars. Once I simplify everything inside, now I can actually take the absolute value. What would the absolute value of 21 be? 21. 21 is just a different distance of 21 from 0. And there's my final answer. That's all I've got to do. Questions on example 2? You okay? Can I move on to my last example?
Yes. Yeah.
Okay, these 2 sentences up here, let's talk about these. When evaluating algebraic expressions, absolute value bars act as a grouping symbol. Perform any operations inside the absolute bars first. That's why I wanted to teach you guys GEMDAS instead of PEMDAS. What does the G on GEMDAS stand for? Grouping symbols. Now we've got another thing of grouping symbols to place under that G when we're doing our order of operations. Parentheses, brackets, absolute value bars, those will all fall under grouping symbols. Does that make sense? Okay. So example 3, evaluate 23 minus the absolute value of 3 plus 4x if x equals 2. Select the statement below to justify each step. So as I do a step, I've got to pick one of these statements to justify that step. Okay? So I put it on this slide to give myself some more room. What do you guys think we need to do first?
Multiply 3 plus 8 plus 11. Fill in.
3 plus 8 is not multiplication.
Oh yeah.
Yeah.
Oh my God.
Just
Put the 2.
yeah, put the 2 there.
Yeah. Before I do anything, before I can do any of my operations, I don't know what everything is yet because I haven't plugged anything in. It tells me x equals what?
2.
2. So the very first thing I need to do is replace my x with 2. 23 minus my absolute value. 3 plus 4 times 2.
4 times 2.
Are we okay with that first step? What statement would justify that step? Replace x with 2. Questions on my first step?
No.
Okay, after you plug in 2, what would you guys do next?
Multiply.
Multiply. We're doing an order of operations, right? GMDOS, what does the G stand for? Grouping symbols. Do I have grouping symbols?
Yes.
Yeah, like I said on my previous slide, absolute value bars are grouping symbols.
Yep.
So I've got to do everything inside those bars first before I can move outside the bars. So I've got addition and multiplication in there. What would come first? Multiplication. What is 4 times 2?
8.
8. What statement would justify this step? Multiply, right?
Yep.
We okay there?
Yep.
Questions up to this point? Do I still have stuff going on inside my grouping symbols? Yeah, so I still need to keep going inside there. What's 3 plus 8?
11.
11. What statement goes there?
3 plus 8 equals 11.
Yep, 3 plus 8 equals 11. Now, do I have anything else going on inside the absolute value?
Yes.
No. So I can move outside and actually take the absolute value of 11. What is the absolute value of 11?
11.
11. So this turns into 23 minus 11. We okay with that?
Yeah.
Which statement justifies that step?
11.
Absolute value of 11 equals 11. Right? I'm using these statements up here to justify my steps. Everyone okay with where I'm getting these statements from? Okay? They gave me the statements. I've just got to pick which one goes with the correct step. The absolute value of 11 equals 11. Right? Now, I've got one more thing to do, one more operation. 23 minus 11 gives me what? 12. So there's my answer. What statement goes with that step?
Simplify.
Simplify.
Simply. Oh my God.
Okay.
Simplify.
Shh. Are there any questions on this example? So, if you're evaluating an expression using your order of operations and you have absolute value bars, those count as grouping symbols. So you've got to do those first, just like you would parentheses. Everyone got it? Are there any questions about any of the notes we just took? What is an absolute value? They're the bars, yeah, but what does it tell me? It's positive. Why is it positive? Something having to do with 0.
How far is from 0?
Yeah, the distance it is from 0, right? Absolute value tells me the distance a number is from 0. Everyone okay with that?
Yeah.
And then we treat absolute value bars like grouping symbols. Okay? Are we good? Yes.